All right, guys, so this is our kinematics remediation. I want us to look through this one problem. So a car is traveling 20 meters per second, sees a deer, takes 0.5 seconds, that's what that says, not a bad word, to react, and then slows at 3.5 meters per second each second. If the deer is 50 meters away, do they stop in time? So I'm just going to go through solving this. I'll pause it a couple of times to ask you some questions, and then we will be good to go. So I'm going to start by drawing a picture. So I've got my car, okay, traveling, and it sees a deer. We know I'm all an artist. That's a deer, okay? And we have this distance here is 50 meters. So we want to know, does it stop in time? So the key to solving this problem is that there's two parts. There's the reaction, okay, and then there's the slowing down. So the reaction, they're going to continue traveling at a constant speed, and then they're going to slow down. That'll be an acceleration, okay? So in part one, if you're reacting, you're going at a constant speed, you just need to do distance is equal to velocity times time. So how far does it travel during that part of the time? So to do that, we would do 20 meters per second times, what did I say, half a second? Okay, and so that tells us that it went 10 meters just during that time right then. Now part two, we're going to write out the variables we know. So we know it started going 20 meters per second. That's 20 meters per second. We know trying to stop, so the final is going to be 0. And we know the acceleration is negative 3.5 meters per second, or meters per second squared. Okay, so that's the second part of this problem. I'm trying to find how far it travels during that time. So for this one, I'm going to use my equation, and I'm actually going to go over here to solve this. So let's draw a line here, right here. V squared equals 2a delta x plus v naught squared. So plugging in my numbers, I have 0 equals 2 times negative 3.5 times delta x plus 20 squared. All right, so we solve that out algebraically, and we get delta x equals 5.7 meters. Okay, so that's how far the car traveled during the second part of the motion. So then we look at how far did it travel in the beginning, 10 meters, 5.7 meters, total delta x, 15.7 meters. So we've got plenty of time to stop before we hit the deer. So now I'm going to ask you some questions. You're going to go ahead and answer them, and then you'll be done. Thanks for listening.